Okay, what's up? What's up? And cool. So, सीक्वेंस पढ़ना है नहीं पढ़ा कुछ भी अब तक. Some notes I have really some notes with me. So पहले क्या करते हैं, नोट्स गो थ्रू करेंगे, आसान दिखे तो वो पढ़ लेंगे. एंड मेरे पास कुछ इम्पोर्टेंट क्वेश्चन थे. ये मैं बनाया था जीपीटी से. आज बैठ जाना पड़ता ब्रो, ना pretty sure I'm messed up. ज़्यादा नहीं करा मैं तो need to like sit and complete all this. So ये करना है कि मैं 3 पहले करा एक बार. ये करना है कि मैं 5 पहले एक बार करा. This is also easy only. I think I shouldn't touch unit 2. I should not touch this because I didn't do it at all. And this also I did once, so this is something I could do. टू अब तक टच नहीं करा है, थोड़ा बहुत सिर के ऊपर से जा रहा है. 2 ऑल दो 2 मार्क्स के करेंगे. 2 मार्क्स है 2 फॉर द सेकेंड यूनिट. एंड आर एस एल्गोरिथम बहुत पूछ रहा तो आर एस भी कर लेंगे. तो दैट इज़ द थिंग. So I would not, I don't want to put myself into videos. I would rather want to look into some notes that give me like straight up information. And I think I do have a link of notes. Let me get that. Give me a second. Before that, I need to open WhatsApp, so I'll just close this for now. Just give me a second. Wait, no, I think this is not a good way to do this. Yeah, this is how I probably should do this. Screen is not the best. Give me a second. Oh no, I'm not sure. Let's clean it now. I don't think I should be doing that. Okay. I couldn't find it. So I got something over here. This looks kind of nice. So string and 3 right. Simple key encryption. Mathematics. And yeah, that's about this simple key encryption. Another appearance stage here. Oh, this is trying to get some coffee. Otherwise, I'll wait for some time. Yeah, give me a second. Oh, damn, actually, this is not the right one. This should be the right stream number then, yeah. Domestic tests always give you the right result because it gives an algorithm of tests. This is the represents trial division, formats, primarity, test based on secretary. Acha. Faster but may give a smaller probability of error, often used in case of analysis. I just want to go through this for a second. Uh, and practice. Let's say that's like important topics. I hope no one saw that. Oh, this is so embarrassing, man. Oh, wait. Come on, man. Don't show me political stuff when I'm on my channel. No one saw that. I was just so embarrassed. I hope no one saw that. Oh my god, this is so bad. I hope no one saw that. Right, great. Chinese remember that it uses a set of congruent equation with one variable but different models. Bro, this is. Oh man, I don't understand this.
Hello everyone, welcome back. In this presentation, we will focus on understanding the Chinese remainder theorem and we will also solve example number 1 in Chinese remainder theorem. As usual, let's start the session with the outcomes. Upon the completion of the session, the learner will be able to outcome number 1 example. Let me tell you the theorem first. The Chinese remainder theorem, simply CRT, is used to solve a set of different congruent equations with one variable but different moduli which are relatively prime. It means we are going to have a set of different congruent equations. It's clear that these congruent equations are different but with only one variable and different moduli. So we are going to find the value of this one variable using Chinese remainder theorem. I know things will be a little bit not clear for you at this stage. Anyway, when we see some examples, you will understand this. Before that, let's have a theoretical understanding. So we have different congruent equations as mentioned in the definition, where x is congruent to a1 mod m1, x is congruent to a2 mod m2. We have n equations, x is congruent to an mod mn. If you see here, we have one variable which is x here, right? And we have a set of different congruent equations which is this. We have n different congruent equations. And if you note here, there are different moduli. This is mod m1, this is mod m2, this is mod mn. We have n different equations with different moduli, different a values, but the variable is 1. Now we are going to find the value of this single variable. Let's see what the Chinese remainder theorem states. So Chinese remainder theorem states that the above equations have a unique solution of the moduli are relatively prime. So m1, m2 up to mn, when they are relatively prime to each other, then there exists a unique solution x. I hope the theorem is clear for you. If not clear, no worries. Let's solve example number 1 and you will understand things clearly. Before diving into example number 1, what is the formula for finding this value of x? So the value of x can be x is equal to a1 m1 m1 inverse plus a2 m2 m2 inverse up to an mn mn inverse mod capital M. If you note here, few values are available on the question. a1, a2 up to an can be taken from the question, and we are required to calculate the other unknown variables, including this mod m, using the values that are available in this set of congruent equations. So this is the equation which is used to find the value of x. Let's see example number 1. Solve the following equations using Chinese remainder equation. So this is the equation which is used to find the value of x. Let's see example number 1. Solve the following equation for mod 7. How many equations are given in this question? 3 equations. So we are going to modify the formula in such a way that it is going to capture 3 different congruent equations. You can adjust the formula according to the need. Let's solve this now. We are going to have the equation like x is equal to a1 m1 m1 inverse plus a2 m2 m2 inverse plus a3 m3 m3 inverse whole mod m. Why we are stopping up to m3? Because we have 3 equations, 1, 2 and 3. If you have 4 equations, then add plus a4 m4 m4 inverse mod m. So it's so simple. Since we have 3 equations mentioned in the question, our formula goes like this. Now let's see what are the given data. In order to find the given data, let's see this with the comparison. We know Chinese remainder theorem, we have different congruent equations like this. X is congruent to a1 mod m, since we take 5 is 2. So that's what we have mentioned here. A1 is 2, A2 is 3, and A3 is 2. Then what are the other given data? Small for leaders, no 5, A, M, small M1, M2, M3. These are all big M1, M2, M3. So we are required to find capital M1, capital M2, capital M3, and capital M1 inverse value of capital M, which is this. So we will find all these values. Once all these values are known, we know A1, A2, A3 are already given. We'll get our A1, A2, A3, small M1, small M2, small corresponding inverse, also capital M. To find capital M, it's so simple. It's the product of all these small m's. So we have small m1, small m2, small m3, right? So capital M is the product of small m1, small m2, and small m3. So when we substitute this, we get capital M is equal to 3 into 5 into 7, which is equal to 105. So we found the value of capital M, which is 105 here. We are done with finding capital M. Let's now move on to find capital M1, capital M2, and capital M3. So let's navigate to finding capital M1, capital M2, and capital M3. How to deal with this? So we are going to find 3 values: capital M1, capital M2, and capital M3. So the formula is capital M1 is equal to capital M upon small m1. That is what we have found here, capital M upon small m1. Similarly, capital M2 is equal to capital M upon small m2, and capital M3 is equal to capital M upon small m3. We know the values of capital M and all small m values, right? We will just substitute it here. So when we simplify this, we get capital M1 as 35 and capital M2 as 21. Why 21? Because capital M is 105 and small m2 is 5, which is this. So we get capital M2 as 21 and capital M3 as 105 upon 7. Why 7? Because small m3 is 7. So when we substitute this value, we get capital M3 is equal to 15. Now we have found out the values of capital M1, capital M2, and capital M3, which is 35, 21, and 15 respectively. It's so simple. We know capital M1, right? So we are going to find the multiplicative inverse of this capital M1. So when capital M1, when it is multiplied by its multiplicative inverse, we should get remainder 1 when we perform with mod small m1. Please focus on this row. So when this value is multiplied by its inverse, we will get 1 as the remainder under mod m1. Similarly, capital M2 is multiplied by capital M2 inverse, will give 1 under mod small m2. Similarly, capital M3 is multiplied by capital M3 inverse will give 1 under mod M3, which is small m3, which is this. So we will substitute the values what we have found. So let's focus on that's what we have found it in the previous step. So we have 35 is multiplied by capital M1. So let's start with y. Then 35 divided by 3, you get 2 as the remainder. So M1 inverse is not 1. Let's try 2. So 35 into 2 is 70. 70 when it is divided by 3, we get 1 as the remainder. So M1 inverse is not 1. 5 when it is divided by 3, you get 2 as the remainder. So M1 inverse is not 1. Let's try 2. So 35 into 2 is 70. 70 when it is divided by 3, we get 1 as the remainder. So we have M1 inverse as 2. We easily found it out because all these values are when it's not 1. When it is divided by 3, you get 2 as the remainder. Are you getting 1 as the remainder? 35 when it is divided by 3, you get 2 as.
Wait. 1 mod 3. 1, 3. What was mod in this? How do you take mods? पागल है क्या? मॉड समझा नहीं क्या? मॉड 3 That's what I thought. 1 modulo 3 is 1 rate. तो लाइट करते हैं म्यूट वाइट भी कंफ्यूज हो रहा हूँ.
As the 35 into 1 is 35, then 35 when it is divided by 3, are you getting 1 as the remainder? 35 when it is divided by 3, you get 2 as the remainder. So M1 inverse is not 1. Let's try 2. So 35 into 2 is 70. 70 when it is divided by 3, we get 1 as the remainder. So we have M1 inverse as 2. We easily found it out because all these values are small numbers, so I'm not going for extended Euclidean algorithm for
What the hell, man? 1 mod 3 1 है तो अच्छा मे बी 1 आंसर आना बट यहाँ पर मॉड 3 करना पड़ता था शायद. इसको भी मैं मॉड 3 अगर करा था तो मेरे को मिल जाता या नहीं. अगर दैट इज द सिनेरियो. whereas in 70 अगर करे समझो अपन डिवाइड 70 डिवाइडेड बाई 3 करे अपन ज़्यादा मैं अपना कर लेता हूँ. नहीं मैं टाइम वेस्ट करूँगा. 1 रिमाइंडर आ गया. ओके कूल मैं समझ गया. सिमिलरली M2 इंटू M2 बार M2 क्या है अपना 21 इंटू M2 बार M2 अगर इसको 1 रखा हमने तो 21 बनता है. 5 से डिवाइड करो 5 4 20 5 5 20 है. नहीं इसका करना है 42 बनाया. नहीं आई थिंक आई नो 42 into 2 2 the 4 4 2 the 8 84 is the right answer because 85 तो बन जाता 5 से. This should be 3. Yeah, 3 it is. Oh.
21. 21 when it is divided by 5, we get 1 as the remainder.
Do I not understand modulus? Yes, I don't understand modulus. is stupid man. Like, what am I even doing? This is wrong. Mod means कि तुम डिवाइड करना उसको पूरा डिवाइड होना है. How can I be so dumb man? 1 mod 5 तो ये 5 से डिवाइड होना. Yeah, it's pretty decent. मैं समझ गया actually. फिर I want Chinese के फिर मैं पूछता मैंने but I'm just doing it.
So Chinese remainder times 21 and the remainder is 2. Perfect. So we found out the value that is 20, remainder is 3. So this is also perfectly fine. Let's move on to the third equation. 23 is congruent to 2 mod 7. 23 when it is divided by 7, 7 3 times 20.
अच्छा तो बेसिकली मतलब x को मेरे को मॉड करे तो मेरे को ये वैल्यू आना. It's more towards that. I'm so tempted to see this one message on WhatsApp and it's just WhatsApp is such a big distraction for me honestly. I just hate that app man. I hate it. I genuinely hate it. I hate WhatsApp. I want to like quit WhatsApp forever. I just really want to quit WhatsApp forever. But yeah, this was a very nice video. Okay, so congruency 8. I don't know what this means. X mod n1 x little mod n कहाँ से आया भाई. RSA cryptography, reverse Shami and all women, exponential congruence. Just two exponents E and D, where E is public and D is private. Suppose P is the plain text and C is the ciphertext. Sender uses C is equal to P bar P mod N to send ciphertext C from receiver. Oh my goodness, this is so disgusting. Oh my, receiver uses P is equal to C mod D. C mod D. So we have like E is the public key and then D is the private key, right? The modulus n is a very large number is created during the key generation process. Encryption and decryption use modular exponential. Modular exponential is feasible in polynomial time using the fast exponential algorithm. However, modular exponential is as and stops factor in the modulus, for which there is no polynomial algorithm. This means that the sender can compute in polynomial time, receiver can also decrypt in polynomial time. If not approved, because she has to compute the here through C.
Welcome to our channel. In the last session, we discussed wrapping crypto system. Now, in this session, we are moving to Elgamal crypto system. Here, this Elgamal crypto system is mainly based on discrete logarithm algorithm. Mainly based on discrete logarithm algorithm. It's simply, suppose if I have an equation, some E2 is equal to E1 power R mod P. Now, calculating the powers with modulo A prime, it is very easy by using a fast exponential algorithm. But if I have the powers with modulo A prime. Now calculating the powers with modulo A prime, it is very easy by using a fast exponential algorithm. But if I have the values of E1, E2 and P, now if you want to calculate R value log E2 base 1 mod P, now it is very difficult to calculate the value of R, even you know E1, E2 with P, because it uses the discrete logarithm. This discrete logarithm provides security. Clear? The to power modulo A prime is very easy, but to calculate discrete logarithm is a very difficult. Now, how this Elgamal cryptography is performed? Now, what is the procedure to generate the keys encryption? and decryption. Assume if Bob is the receiver, before encrypted the message, first the keys are generated by the Bob. What is the first step? The first thing is key generation. How the keys are generated? First, simply he select a large prime number P. We consider along with one example, Bob select a large prime number P, assume some P value is equal to some level. It is a prime number. After this, he select a value D. After that, first after coming the P, he select a value D such that D is also belongs to the group G is equal to ZP star comma X. We already know ZP star. What is ZP star? Simply the set of numbers that are less than P and the numbers are co-prime to P. So from this, from this group, we are selecting one number D and such that the number is 1 less than or equal to D less than or equal to P minus 2. By satisfying this condition, I am selecting one number D. So according to this example, I am selecting the number D is equal to 3. And select one more number E1. Now E1 is simply a primitive root of P. Now E1 is simply a primitive root of P. Select E1. Here this is okay, ZP star comma X. Select E1. What is the condition? E1 is simply a primitive root of P. We already know the primitive roots. Based on this, I am selecting E1 value. Okay, first randomly I choose as a large prime number P. Based on the condition, the number belongs to the group and the value is 1 less than or equal to D less than or equal to P minus 2. Based on this, I selected one D value and based on the P, I am selecting E1 such that E1 is the primitive root of A and then calculate E2 value. E2 is equal to E1 power D mod P. So I am calculating E2 value. E2 is equal to E1 power D. So we are calculating answer E1, that is 2 power D, 3 mod 11. So 8 mod 11, the answer is 8. Like this, I am doing all these operations while key generation. In this, what are the public key and what is the private key? In this, D is the private key. Remember, D is the private key, E1, E2 and the prime P. This is the public key. Now, once the keys are generated, the public key E1, E2 and the E public key are published. Once the public key is available to the sender, assume Alice is the sender. Once the public key is available to the sender, what the sender do? Simply do the encryption operation. So, key generation is completed. What is our next step? Our next step is do the encryption operation. Here, the Alice generates 2 cipher tests. Instead of generating only one cipher test, here the sender generates 2 cipher tests in the encryption process. Now, what is the cipher test? C1 is equal to E1 power. Before doing the encryption, he randomly selects. Remember the point? He randomly select a number R. Randomly select a number R and calculate C1 is equal to E1 power R mod P. C2 is equal to E2 power R into plain text. So mod P. Assume this is the plain text I am given. Assume PT is my plain text. On this plain text, he perform encryption and generate 2 cipher tests. The first one is C1 is equal to E1 power R mod P. C2 is equal to E2 power R into plain text mod P. Parallelly, I am doing the calculation. Assume any random number, suppose R is equal to 7. R is equal to 4. Whatever the number you are taking, do with that number. R is equal to 4. Take any plain text. Suppose take a plain text value is equal to 7. First to calculate, C1 is equal to E1 power. What is E1? 2 power R. 2 power R. R value in the sense 4. 2 power 4 mod P. P in the sense my prime number. So 2 power 4 means 8. 8 mod 11. Sorry, 2 power 4 means 16. 8 mod 11. Simply 16 mod 11. 5. 2 power 4 means 16 mod 11. That is equal to 5. And calculate the second cipher text. C2 is equal to, what is my plain text? 7 into E2. What is my E2 value? 8 power R. 8 power R into mod 11. Simply calculate 8 power 4. 8 8 is 64. 64 into 64 mod 11. Multiply into 7. We are getting. Do the calculations. Already we know all the calculations. Simply if you do the calculation, we are getting a value 6. We already know how to do the modulate operation, inverse module operation. Every mathematical concept is already completed. So please go to that one. Now C1, C2, my encryption is completed. Now this is received to. Now C1, C2 are moved to Bob. Now what the Bob to? Take this C1, C2 and apply the private key. Take C1, C2, apply the private key. Now he decrypt the message. What is the formula for decryption of the message? Simply, we are getting the plain text as C2 into C1 power D minus 1 modulus P. So don't confuse, it is very easy. What is C2 value? C2 is equal to simple calculations. E2 power R into PT. C1 power D. If C1, what is C1? Again, E1 power RD. E1 power RD. If you are doing modulus calculations, everything is cancelled. Finally, plain text is available. This is the formula for generating the plain text. Anyway, according to this example, what is C2? 6 into C1 is 5 is available. This is the formula for generating the plain text. Anyway, according to this example, what is C2? 6 into C1 is 5. What is B value? 3. 5 power 3 minus 1 modulus 11. First time you calculate 5 cube. 5 cube value is equal to 125. What is 125 mod 11? You already know you can apply the modulus operation any number of times. Instead of 125 power minus 1 mod 11, what I am doing? First I am calculating 125 mod 11. So simply 125 mod 11 the sense 121 is 11 11s are 121. The remainder is 4. Now here 4. Simply 4 inverse mod 11. We know the formula. 4 inverse mod 11. The answer is 3. Now 6 into 3. Now finally what here? 6 into 3 again mod 11. 6 3 are 18. 18 mod 11 that is 7. What is my plain text? My plain text is equal to 7. You are getting the right answer or not? Yes. This is the way to implement Elgamal crypto system. Remember, like Rabin crypto system, it is non-deterministic. It is a probabilistic approach. Means, suppose if the plain text is encrypted for the first time, we are getting one cipher text. If the plain text is encrypted for the second time, you may get another cipher text. That is, the same plain text generates different cipher text each text. If the plain text is encrypted for the first time, we are getting one cipher text. If the plain text is encrypted for the second time, you may get another cipher text. That is, the same plain text generates different cipher text each time when you apply. Why? In encryption, I am using a random number. Because of this random number, it generates a different cipher. Getting one. Even. What is the condition? Even is simply a primitive root of t. We already know the primitive roots based group, we are selecting one number D and such that the number is 1 less than or equal to D less than or equal to P minus 2. By satisfying this condition, I am selecting one number D. So according to this example, I am condition. I am selecting one number D. So according to this example, I am selecting the number D is equal to 3. And select one more number E1. Now E1 is simply a primitive root of P. Select E1. Here this is okay. ZP star comma X. Select E1. What is the condition? E1 is simply a primitive root of P. We already know the primitive rules. Based on this, I am selecting E1 value. Okay, first randomly I chooses a large prime number P. Based on the condition, the number belongs to the group and the value is 1 less than or equal to D less than or equal to P minus 2. Based on this, I selected one D value and based on the P, I am selecting E1 such that E1 is the primitive root of A. And then calculate E2 value. E2 is equal to E1 power D mod P. So I am calculating E2 value. E2 is equal to E1 power D. So here I am calculating upside E1, that is 2 power D, 3 mod 11. So 8 mod 11, the answer is 8. Like this, I am doing all these operations while key generation. In this, what are the public key and what is the private key? In this, D is the private key. Remember, D is the private key, E1, E2, and the private P. This is the public key. Now, once the keys are generated, the public key E1, E2, and the public key are published. Once that public key is available to the sender, assume Alice is the sender. Once the public key is available to the sender, what the sender do? Simply do the encryption operation. So key generation is completed. What and equal to power, that is equal to C the plain value formula for generating the plain text. Anyway, according to this example, what is C2? 6. What is C2 value? C2 is equal to simple calculations E2 power R into PT, C1 power D. If C1, what is C1? Again E1 power RD. E1 power RD. If you are doing modulus calculations, everything is cancelled. Finally, plain text is available. This is a formula for generating the plain text. Anyway, according to this example, what is C2? 6 into C1 is 5. What is D value? 3. 5 power 3 minus 1 modulus 11. First I will calculate 5 cube. 5 cube value is equal to 125. What is 125 mod 11? You already know you can apply the modulus operation any number of time. Instead of 125 power minus 1 mod
In this session, we will discuss Diffie-Hellman key exchange. So, Diffie-Hellman key exchange means we have to exchange a key between different users to perform encryption and decryption operation. The procedure for calculating Diffie-Hellman key exchange is first select two numbers and make them as public. Select two public numbers. Among them, one number assumed as q. Suppose q is a prime number, and select a number alpha such that alpha is a primitive root. Alpha is a primitive root of q. Once the two numbers are selected, suppose if user A and user B wants to exchange keys. If user A and user B wants to exchange keys, first user A generates a random number xa. User A generates a random number xa, and this value is less than q. Similarly, user B also generates a random number xb, and this value is also less than q. Once xa is generated, based on xa value, user A calculates ya, user B calculates yb. The user A calculates ya is alpha power xa mod q. Alpha is a primitive root, xa is the user A random generated key. Similarly, yb is equal to alpha power xb mod q. So these are the two keys generated by user A and user B. In this, all x represents private key, and y represents public key. That means xa is the private key of user A, ya is public key of user A. Similarly, xb is a private key of user B, yb is a public key of user B. Once xa and ya, xb and yb are completed, now concept is to generate a key. Suppose ya is transferred to